Okay, so as I said, this is our last section of the chemistry unit, part 3. I hope to get this in about a week and a day, so we won't be having, I don't think we'll be having a test next week, because this is a shortened week, and then next week on the 20th, you guys, I believe, have your literacy test, right? That's that online version of the literacy test. So we will be losing that day as well. So I don't think we'll be ready for a test quite next week, but it'll be early into the week after that. Yep. There is later on in the month, not within the next 2 weeks. I think it's maybe 3 or maybe in the 4th week after that. But there is another one coming up. Okay. So what have we done so far in the chemistry unit here? Well, number 1, we learned about atoms and the periodic table and where to find the metals versus the non-metals and all that other good stuff. What do we got here? What are we looking at here? See, you just did a click over. See, you need to either put that down on your desk so I can see the note, all right? Or you need to get a piece. Well, you also need to get a piece of paper out, or you got to get a device. You got to do something. You're not just going to sit there.
No, I'm going to type it up in Google Docs.
Okay, well, if I see that you do click to switch out, I'm going to take that away.
All right.
It's that simple. All right. So up to this point, like I said, part 1, we learned about atoms in the periodic table and how to draw those atoms, Lewis diagrams, all that good stuff. And then the second part, we learned about what happens when we put the atoms together. And when we put those atoms together, we get compounds. And we talked about ionic compounds versus molecular compounds, how we can distinguish between them in terms of their properties and all that good stuff. In the last section, we are going to talk about chemical reactions. So what we're going to be looking at is what happens when we put chemical compounds together. What if we put 2 compounds together? Do we get a reaction? Do we get something that takes place? And that's what we want to look at. To begin with, for the first 2 days, we're going to look at just chemical reactions themselves. How do we write them down? How do we express them? And that involves what we call chemical equations and ultimately balanced chemical equations. And that'll be the first couple of days. Then after that, we're going to talk about types of reactions. Chemical reactions can fall under certain groupings. An example is a combustion reaction, when something burns. So we will be looking at these different types of reactions and doing a few experiments that are along with them. To finish off, we're going to talk about a special pair of chemicals that you, I'm sure, have encountered before. And with that, what we're talking about there is acids and bases, and what makes a chemical an acid, what makes a chemical a base, and how they can neutralize each other. And then that'll be the end of that particular section. We'll then have a test. Like I said, not next week, but maybe the week after. Okay, so let's continue on. So let's define what a chemical reaction is. So again, at the very beginning of this unit, we also talked about chemical change, where we have new substances formed, and those new substances we call the products. So during a reaction, we have the substances that we started with, the reactants, and then the substances that we end with, the products. Now again, we need to do a quick little review of how we know whether a chemical reaction has taken place. If you guys are on your own devices, you may have gone to the next slide, and that's that review of evidence for a chemical change. You can start writing that down if you've got your device. Once we get everyone who is caught up here, various people are looking at devices. So how do we know a chemical change has taken place? Well, we have 5 pieces of evidence. A change in temperature, it gets hot or cold. Hot is one that we're usually used to. A combustion reaction tends to give off heat, makes things hot. But if you've ever had one of those cold packs, if you've ever hurt yourself in a sport and the trainer takes one of those cold packs and mixes a couple chemicals together on the inside, they got to pop this thing. That gets cold. So we can also have cold chemical reactions. Change in color, that's pretty obvious. Some dramatic new color is produced. Formation of a gas, it bubbles. I think we saw that all in that baggy science lab that we did. Formation of a precipitate. A precipitate is when a new solid is produced. And production of light. In our next unit, we're going to be talking about light and how light behaves. It's a physics unit on what is called optics, the way light interacts with things. And we'll talk about how light is produced, and they can be produced in chemical reactions. If you've ever seen those, you know, sometimes they have them as necklaces type things, you know what I mean? They're plastic, you bend them and it breaks something on the inside, you give it a shake and it glows, right? That's a chemical reaction that's producing light. We'll take a look at that then. Okay, so now that we've recalled how we identify whether a chemical reaction takes place or not, we are next going to talk about how we express that chemical reaction, and that is using something called a chemical equation. All right, again, I'm looking at various people writing on various things. So representing chemical reactions. Two ways in which we can write chemical reactions. One's called a word equation, and we're going to talk primarily about that today. And then tomorrow we will talk about putting the chemical formulas in for a balanced chemical equation. Either way, the reactants are always on the left, and the products are always on the right, and they're separated by a reaction arrow. Now that's a pretty big fancy arrow. It does not need to be that fancy. That's good enough. Right, when you're doing your note, just an arrow pointing towards the products. So reactants progress to become products. Pretty straightforward stuff. You may have talked a little bit about this in grade 9. I'm not sure. I haven't taught grade 9 in a long time. Again, everyone is at various spots. So let me know if I've got to go back. Okay. So, two forms of chemical equations. typing on your phone, subscript becomes tricky. It can be done. If you go up to the top, you can get it to become a subscript, but it's like many little keystrokes. It's kind of a pain. So the word equation involves the names of the reactants and products, so just what they're called, using their names. And the example that I'm using here is carbon reacting with oxygen in a burning situation, kind of like if you had a piece of charcoal, if you were barbecuing. And in the end, that carbon produces something called carbon dioxide. And it simply describes what's happening in the reaction. Very straightforward. Two, we have what we call a chemical equation. And that's where we have the chemical formulas, as I taught you in the last section. So in this case, here we've got carbon. And if you read that little bit at the end of the test, that's excellent. And I've got a little subscript S. And what does that S stand for? What does that S in the chemical equation stand for? Any idea? If you read it? If you didn't, it's not a big deal. Yep. Solid. It tells us the state. So the S stands for solid. What do you think? Well, before I get to G, sometimes we see an L, like a script or a written L. What do you think L stands for? Liquid. And then G, what does G stand for? Yep, it's in the gas state. Nice. And there is one other that I don't think was necessarily in the book, but I'm going to put it down anyway. Some say AQ. An A and a Q. Any ideas what that AQ is? No, it's not plasma. It's not that state of plasma. Nope. AQ. It stands for something that we say is aqueous. It means we've dissolved it in water. So if we have an AQ, it means someone has taken that substance and dissolved it in water. All right? So AQ stands for aqueous. It means dissolved in water. All right? Dissolved in water. Because very often we'll dissolve substances in order to do chemical reactions. Okay. So you can see here we've got carbon, solid, O2, which is a molecule of oxygen gas. They combine and it produces CO2, which is carbon dioxide, and it is also a gas. Okay? So those are chemical equations. Let's do a few examples here. So I'm hoping you can fill in the blanks. Again, if you're using pencil, that's excellent. When we take these up in a moment, if you've made a mistake, not a problem, because if you've got pencil, you can erase it. Zinc and oxygen, they combine to form zinc oxide. So if copper gets together with bromine, what might our product be if copper gets together with bromine? Yep, Zach. Copper bromine. It's going to make the compound. copper bromide. Here I'm telling you one of the reactants is sodium. The product that is formed is sodium chloride. What was the other reactant? What was the other reactant? Logan, what do you think? Chlorine. Very good. Chlorine. Now for the last one, it's a little tricky. We've got some copper, and then we've got some silver nitrate. In the end, one of the products is silver, and to be honest, my line is not nearly long enough there for my answer. What do you think has to be left after that particular scenario? What do you think, Cade? Yeah, it's copper nitrate. This is what we call a single displacement reaction. We'll talk about this more later on in the week, but the copper displaced the silver in the compound. So to keep everything that we had at the beginning, because we've got to make sure we have the same stuff, we end up with copper nitrate, right? Copper nitrate. Excellent. Now, these are some very simplistic reactions. There are very many complex reactions that exist in nature. But again, we're just introducing this to you guys, so we're starting off with some pretty straightforward ones. Okay? All right. Let's now take some statements and write the word equation for them. So let's try to write the word equation for these. So you can get the names of those things? Yep. Actually, for this example, you would need a periodic table, but for the rest of the examples and the textbook questions, I don't think you do need one, but I can put that down. But you're also going to need to know what this SO4 is called, right? And that's on our sheet, and not everyone has that. Does anybody remember what the SO4 is called? That's in that block. Sulfate. That's a sulfate, correct. So the SO4 is a sulfate. So what is this first chemical called? What is this first chemical called, Cade? No, we don't put the di because it's ionic, so we don't do that. So sodium, and what's that SO4? So sodium sulfate. And I'm going to write it underneath here because I'm just afraid I'm going to run out of room off to the side. You guys are able to write it smaller. Sulfate. Now, what do I put between the reactants? What symbol goes between? Plus. Plus. And what's the name of that stuff? Eric?
Lithium chloride.
Yeah, lithium chloride. And reacts to form. So what do I put now? I put the arrow. Doesn't have to be a fancy one. Doesn't even have to be very long. Product names. Pick up some other people. Tyson, what's the name of that first one there on the product? Yeah. And the last product. The last product. What's it going to be? Max, what do you think? Yeah, lithium sulfate. This is called a double displacement reaction. You can see it's like they traded positions. Again, we'll talk about that more in the future. Okay, so let's try the second one. The second one, you'll notice, is more of just a statement of what happens. Oxygen and glucose are produced when plants perform photosynthesis. The reactants are carbon dioxide and water. So for the chemical reaction, I just need the reactants listed and the products listed, separated by that arrow. So what are our reactants in this one? Yep. Carbon dioxide. Again, you don't have to write it down below. I'm just knowing I'm going to be running out of room here. Plus water. And what are the products of this? What are the products? What is formed in this reaction? Yep, Tyson? Oxygen and glucose. Oxygen and glucose. All right? Okay, now, at this point, there's a few questions that you can do out of the textbook. Now, I'm not going to let you work right now because I want to continue on and talk about counting atoms, because I think this is pretty straightforward stuff. So I'm going to continue on and talk about counting atoms, and then once we get through a bunch of those examples, I will then let you work on whatever needs to be worked on. In terms of the textbook questions, in Google Classroom, I've put the PDF for those pages. So you could open up your document and read those pages to get those. But you can also grab a textbook if you'd like. If you're not going to take the textbook home, that's fine. You can leave it there. But if you are, I'm going to sign it out to you. I'm going to take the barcode number and I'm going to make it officially signed out to you. A couple of people had textbooks signed out the other day. They wanted to take it home in order to do that type of stuff. So if you were going to do that, I would sign it out. But you can also access it on the digital copy. So let's continue now, once we get the homework written down. Got it written down? You going to get it down? Yeah, write that homework down, please, so that you know what you need to do. And again, that homework is very much about word equations. And then what I want to talk about now for the rest of the class is how we count atoms in formulas. Because tomorrow we're going to continue on and we're going to talk about what is called balancing chemical equations. And this involves a little bit of math. So what we need to do for the rest of the, well, not the rest of the class, but to finish off this lesson, is go over some straightforward mathematics review, and then apply that to when we count atoms in chemical formulas, because it's going to become very important for tomorrow's lesson. Okay, so counting atoms. And you guys are good at writing away, so I'm going to let you write that down. What I'm going to put on this chart paper here is not necessarily something that you need to write down, but it's really more of just a kind of a review. We're going to be eventually counting the atoms of each type in a chemical formula. But sometimes we're going to have to do some simple multiplication. Now you can get your calculator out, you can have it right nearby in order to do that simple multiplication. I have no problem with that. And if you struggle with simple multiplication, then by all means have your calculator nearby and have everything ready to roll, okay? But what I want to do right now is just do a quick little review of some times tables. I know it's sad, maybe. We're what, grade 10? Yes? Yeah, no you can't. So, what I want to do here, very straightforward, is write down a few of our simple times tables. Again, you guys know this. I'm just kind of getting a gauge for how strong you are at this, because this will make life a little easier. Now, I'm not going to insult your intelligence by doing 1 times tables, but I think we can start maybe with a little bit of this. And I know it is what it is, but it's not a big deal. What do we got here first? 4, 6, 8, 10, 12, 14. You know what? I'm going to stop there. We get the idea, right? Let's do a little more complicated here. Now, to be honest, when I get down into this part of the world, my brain doesn't like it either, right? Get a calculator out. If you have to, open up your calculator app. But we have to be able to do these times tables fairly quickly. Let's do the first ones. Let's see if we can do that in our heads. 3 times 3, 9. Nice. 3 times 4, 12, 15, 18, 21. What is it, 24? 24. That's probably about as high as we're going to get there. Because like I said, when we get going, we're going to have to do some multiplication. What's the first one? 16. Again, if you're not seeing this, make sure you have a calculator. There is nothing, I know it's important that we can do that basic math, but I want you to be able to get the answer. So don't worry if you're having to use a calculator for some of this stuff. What's my next one? 20, 24. Is it 28? See, I would have to do a calculator on that. Is it 28? I got to add 4 to that? 28? Is it 34? Oh, see, I believed you. I believed you because I also need a calculator sometime for those. All right, excellent. Let's just do a few more. 5. So what do we got? 25. Yeah, this is the easy one, eh? 35, 40, etc., etc. 6 times 6, 6 times 7, 6 times 8. 6 times 6 is 36. 6 times 6 is 36. 42, I hate that one. 48, I hate that one. Okay. Tyson, you got this mastered? All right. And again, if you have to use a calculator, don't sweat about it. Okay. So let's take a look at this. When we are given a balanced chemical equation, and it comes to the chemical equation we're going to learn about tomorrow, we're going to have the chemical formula, okay? And that chemical formula, Justin, what do you got there? What do you got? What are you doing? Yeah. Again, sorry, did I impose on you? Cause issues? Okay. So when we have a chemical formula, you're going to find that there's 2 things that we're going to need to know about this chemical formula. One is these little numbers here. The little numbers we call the subscript. All right? It's a tiny little number. And it tells us that in this formula, well, what does that 2 tell me in this chemical formula? What does this 2 tell me? Yep. There's 2 chlorine atoms. Notice here that there isn't a subscript beside the magnesium. What does that tell us? What does it mean if there isn't a subscript? There's only 1. So there's 1 magnesium. Now there's a second number that we also have when it comes to balanced chemical equations. And there's a big number that we put in front of the chemical equation, which we call the coefficient. Now in this case, notice that there is no coefficient. Again, it means that there's 1. So the subscript is the small number, and here we have what is called the coefficient, and it's the big number, all right? And again, notice that there isn't a coefficient in front of this, which means that there's only one of them. So if I want to figure out how many magnesium atoms there are and how many chlorine atoms there are, I have to take the coefficient and multiply it by the subscript. Now this one seems overkill. What I'm doing here is almost overdone because you've already told me there's 2 chlorines and we can easily see that there's 1 magnesium. But what if I had a coefficient that was like 5? What would be the total number of atoms? So this is the way I like to do it. Underneath, I like to write down magnesium. That's the atom that I'm working with. I want you to write this down at this point, right? And magnesium has, in this case, it's going to have 1 times 1 equals 1. I've got 1 magnesium atom. Now, where did this one come from? 1 for the coefficient went right there, and 1 for the subscript went right there. There's 1 molecule of magnesium chloride, and in each molecule there is 1 magnesium, so 1 times 1 is 1. Make sense? For chlorine, Cl, my coefficient is still 1, but how many atoms are there in each one? There's 2. So in the end, there is 1 times 2, there are 2 magnesium atoms. Now that's the simplest of simple. Let's now do a few more that are a little more complicated than this. Like I said, tomorrow we're going to be doing something called balancing chemical equations. And what we need to do is we need to balance the atoms. So if we can't count the atoms, we can't balance the atoms. Let's do another example. So let's say in my equation, I had 2 H2Os. The question is, how many H's and how many O's? Patience. It's okay. Underneath the 2 H2Os, I'm going to write H's, oops, and O's. Look, why would I put 2 H's? H's and O's. I have a coefficient of 2, the big number, which means I have 2 water molecules. Each water molecule has a subscript of 2 H atoms. So how many H atoms are there in total? How many H atoms? Yep. It's not 2. Nope. Yep. It's 4. Because we have to multiply the coefficient 2 by the subscript 2. It means that each atom has 2 H's, or sorry, each molecule has 2 H's, but there's 2 molecules. So I've got 4 H's. So I take the big number and I multiply it by the little number. 4. What am I writing down here as my multiplication for the oxygen atoms? I always want the coefficient to go first and then the subscript to go second. Lucas, what am I writing here to figure out how many O atoms there are? 2 times? Nope. Where did you get the 4? What answer? I want O's. I don't want that 4. Again, reminder, I take the 2 from the subscript and the 2 from the, or sorry, the 2 from the coefficient and the 2 from the subscript. So here I'm talking about O. So there's my 2. How many O's are there in water? Lucas? Yeah, because there's no number there. There's 1. 2 times 1. So how many O's are there in total? What's 2 times 1? 2. So in the end, there's 1 in each water, but because there's 2 waters, there's 2 O's in total. Let's do another one. All right, this is fun. because now we've got some brackets in here. Barium, phosphorus, and oxygen. I have no number in front. So what does it mean? What number is there? If there's no number in front, what does it mean? 1. So you know what you can do? You can actually put the first part. 1 times, 1 times, 1 times. Now I need the subscripts. What am I putting for barium? I'm putting 3. 3 barium. 1 times 3 is 3. Now comes the tricky part. Phosphate contains PO4, but I have 2 of them. So how many phosphorus are there in this thing? Logan? 2. 2 times 1. There's 2 of them. How many oxygens are there in this substance? How many oxygens are there? What do you think? 8. There's 8 of them. There's 4 O's in each one, and each one and there's 2 of those, so there's 8. And now we can finish it off. So if there's brackets, you've got to do a little multiplication as well to get each one. So in 1 barium phosphate, there are 3 bariums, 2 oxygens, and 2 phosphorus and 8 oxygens. All right? Look at another one. You do this one yourself, and then I'll ask for your response here. Again, just write down K H C O. I have the big number, the coefficient is 3. Again, you can write straight down there. 3 times, 3 times, 3 times, 3 times, all the way to the bottom. Again, comes from there. Now I just need to pick out the subscripts. What is it for potassium? What do you got there, Tyson? What is it for potassium? 1, how about hydrogen? 1, how about carbon? 1, how about oxygen? 3. Pretty straightforward, right? 3, 3, 3, 9. Let me just jump ahead. I think we're getting the idea. Oh, that's a nice complex one. Let's do that one to end off with, and then I've got one other version of it at the end. And then I'll let you work away on some stuff. Strontium, nitrogen, oxygen. What do I put all the way down on the left-hand side? What can I start with really easily? All the way down there. Yep, 5 times. 5 times, 5 times. 5 times, 5 times, 5 times. Strontium atoms. Nolan, what do you got here? How many strontium atoms in this thing? 1. How about nitrogen? What do you got? 2. Excellent. 2 times 1. How many oxygen atoms? 6. 2 times 3. Excellent. Good. Because when you've got brackets, you've got to multiply them in. That's how many there are. So now we can figure this all out. There are 5 strontium 10 nitrogen, and what is it, 30? 30? Is that why we wrote that down? 30. So, just looking ahead to what we're going to do tomorrow. Tomorrow, we're going to have to figure out how to balance it. Now, when you balance something, you can change the coefficient, the big number. So let's imagine that we've got some barium chlorate on the left side, and I've got some oxygen on the right side. Here's the question. If I have 2 barium chlorates, how many oxygen molecules, how many of these would we need in order to have the same number of oxygens? Because I need to have the same number of oxygens. So let's go through the example. So we're going to place a coefficient there so that the oxygens on this are the same as the oxygens in this. So what do? We figure out how many oxygens. But you know what we're going to have to do? We have to figure it out for all of them anyway. When we do an entire problem tomorrow, we have to figure it out for all of the atoms, not just oxygen. We're just going to practice with oxygen today. So we're going to do the same thing we just did. Figure out how many bariums, how many chlorines, how many oxygens. Then the question is going to be, what do I put in front of that O2 in order to have the same number of oxygens? Well, we'll go through the motions on the barium. 2 times, 2 times, 2 times. 1, right? 1 barium. How many chlorines in there? How many chlorines in there? 2. 2 times 1, right? Remember, there's a 1 in there. 2 times 1. So 2. How many oxygen atoms in that thing? 6? 6. I heard lots of 6s being whispered. So 2, 4, and 12. Okay. So the question is, what number do I need here in order to have the same number? Now, some of you are already saying it. We need 6 of them. Nice job. Then you've got it. That's good. Some of you might be going, whoa, how did they do that? If you're unsure, we can reverse engineer the process. I could write down oxygen. I could leave a blank for what I'm multiplying it by. How many O's in each one? 2. And what do we know that this has to equal to in order for it to be the same? We know it has to equal 12. So then the question becomes, what do I put in there that makes that true? And that's what you guys did. You guys did it in your head, and boom, you did it quickly. Excellent. I'm hoping we can see that. We need a 6 there. 6. That means we can put a 6 up there. Okay? And that's what balancing means, getting the same number of each type of atom. That's what we're going to do tomorrow in more detail. Yep?
You got like the answer O12, can't you take the other oxygen and divide that one by the answer you got, and that will give it, like, because that's...
Are you simply you're taking this 12 and dividing it by this 2 in order to find... Yeah, that's what we want you to do. I'm writing it down that way because I guarantee there's some people in this room, when you guys said 12, went, whoa, how'd they get that 12? So I'm putting a plan in place so that when you guys have to balance, you can write it out in such a way that you can see it. Okay? But yeah, that's what we want you to do. Yep. Let's do one more of these. Notice it's the same barium chloride. Oh no, actually, did I change the number? I made it 3. That's evil. Let's do one more. You don't have to write out the whole, put a coefficient, blah, blah, blah. Just put the 2 things. This time I want to figure out how many, notice here I'm looking for the chlorine atoms. In this case, I'm looking for the chlorine atoms. So there happens to be a barium stuck to it. That's okay. But I'm looking to balance the chlorine atoms in this question. So you're going to have to go through the same procedure. we're going to need to do the barium, chlorine, oxygen, 3, 3, 3. We know what that number is. Again, barium is 1. Chlorine is 2. We just did this one. And the oxygen is 6. 2 times 3. And I'm really only interested in the chlorine, but I'll do them all. 3, 6. Ooh, what's that? 18? You guys are better at that than I am. I'm terrible at my simple multiplication. I always have to have my calculator nearby. So, again, I'm going to put down barium and chlorine. And again, blank, blank. Barium, there's 1. Chlorine, there's 2. But in this case, I want the chlorine to be balanced. I want the chlorine to be balanced. So if I want the chlorine to be balanced, that has to equal 6, because they have to be the same. So what do I need as the coefficient? I need a 3. Now, as soon as I make that 3, notice it affects the barium as well. As soon as you make it 3, it's going to affect the barium as well, because it's stuck to it. All right? And that means we also have 3 barium. So that works out well. That means the barium is also balanced there. Notice how they're the same. So tomorrow we're going to get into more detail about balancing the entire equation, but this was just kind of practice. So again, I've created a worksheet with more practice of this. It's on Google Classroom. So again, you can write right on the screen for that one if you'd like. You might be able to type it in. And then you also have that textbook homework. To be honest, I'm not worried about your ability to do word equations, and not right now. I think you guys can do that stuff. I'd rather you work on this worksheet first. You work on that first. Okay? What's that? Completely dead? I'll see if I can, if you need one, I might have to get you a charger or something. We'll get it figured out. Let me just stop my recording here for a moment. Dave.